This lecture is on how to calculate variance and standard deviation for a sample. Now, in the previous lecture, I talked about how to calculate variance and standard deviation for a population. This lecture is almost exactly the same, except now I'm talking about calculating variance and standard deviation for samples. In the future, you'll be dealing with almost entirely samples. You'll only know population values very rarely. And it's very important to understand the difference between population standard deviation and sample standard deviation, and when to calculate each one of them. So what now follows is how to calculate the variance and standard deviation for a sample, using the same data set in the previous lecture. So it should be very similar, just with a few key differences to distinguish between samples and populations. So let's begin. Now imagine you have this first data set that has a mean of 12.6. And everything in the data set is pretty similar, 11, 12, 13, 14, they're all pretty close together. Now imagine we have this next data set that also has a mean of 12.6, but the data set is very spread out. It starts at 1, 1, 2, goes up to 31, 36, 42. We come up with the same mean, but the data set is very different. So how are they different? Well, they differ by measures of dispersion. Dispersion refers to how spread out a data set is about the mean. So variance and standard deviation are the two main measures of dispersion within a data set. So right here I have the calculations for sample variance and sample standard deviation. These are commonly called the definitional equations or the definitional approach, which take a little bit longer but make more sense. In the future I will teach you the computational approach, which is shorter, makes less sense, but it's a lot easier to do. So in this, notice that we're using lowercase n because this is sample size. We're using x bar because this is sample mean, and we're using the letter s to represent standard deviation for a sample. So first of all, I'm going to organize everything into this chart. Imagine that we just have this sample data set, 1, 2, 2, 3, 4, 5. So the first step is to calculate the mean, which I do by adding together those 6 values and then dividing by 6. So I find a mean of 2.83, which I put in here. Now the next thing we have to do is find out what each score minus the mean is. We want to find out how much each score deviates from the mean, which we'll do right now. So we subtract and we get negative 1.83, negative 0.83, and so on. So the next part here is to square those values, because if we didn't square those values and just added them together, we'd get 0, and that's kind of useless to us. So we need to make them all positive. So we square all those values that we just found and get 3.35, 0.69, and so on. Now the next part, the top of the fraction that we're trying to find is the sum of. We want to find the sum of all x minus x bar squared. That's what that capital sigma means. So we add together all of those squared deviations and find a sum of 10.84. Now the next step is to divide by n minus 1. Now if we were calculating the population variance, we would just divide by n. But when we calculate sample variance, we divide by n minus 1. It's kind of an advanced topic, but just understand that if we didn't, it would tend to underrepresent what it actually is. So what we do is we subtract this 1 to inflate what we calculate so it's more realistic. And yeah, it is really a more complex topic, but just stick with that for now. So back to the equations, we find out that the variance is 2.17, and to calculate the standard deviation, we just take the square root of that variance. I take the square root of 2.17, and I find a standard deviation of 1.47. So that's the sample variance and the sample standard deviation. Now we just calculated variance and standard deviation using the definitional formulas, which takes a long time. To speed things up, we usually use the computational formulas instead. They'll get us the same answers, but we won't have to work as hard. And these are the two computational formulas for sample variance and sample standard deviation. They might look a little bit complicated, but really they're not, and I'll show you. So first of all, I'm just going to organize it like this. Now we already know what n is. We know that we have 6 numbers, so I'm just going to replace the n's with 6's. Now we need to find the sum of all x squared and the sum of all x squared. Now they're very similar and people often get them confused, so I have them here side by side to show you the distinction. In the first one, you square all the x's, then add them together, and in the second one, you add together all the x's, then square them. So we find 59 and 289, and I'm just going to put that into the equation. And now that that's there, it'd be pretty easy for us to solve for variance. We just complete that equation and find a variance of 2.17, which is the same as last time. And if we want to find the standard deviation, we just take the square root of that 2.17 to get a standard deviation of 1.47. And that's it. All in all, it's pretty similar to calculating the population variance, except now you're dividing by n minus 1 instead of n, and you're using some different letters. So that's it for this video. Understand sample variance and sample standard deviation and how they are measures of dispersion. Also understand the difference between the definitional formula and the computational formula. The definitional formula being harder to do but making more sense, and the computational formula